Hello and welcome to this question. I will try to solve this truss problem with the method of sections. Let me first copy real quick this problem. Okay, let me try to make it a little bit bigger, hopefully, so you can see. I think this should be good enough. Okay, let's try to solve it as fast as we can. First thing, read the problem carefully. You see the F equal to this. Where is F? Yeah, it's this one right here. This force right here is equal to about 22 kips. Kilonewtons. Okay, so determine the approximate force in the member DE for the truss shown. Okay, D and E. Okay, so this is the one that we're interested in. Change this one to red so you can see it. So this is what we're interested in. So we need to make a cut, but before that we need to determine the reaction so we can which side we should take. I would take always the side that doesn't have forces and stuff in it. I would take this side. So I'm gonna just initiate the cut right here. This is the cut. What I will do, I will first sum the forces here, not the force but the moment, so I can get this force right here and I don't worry about this one. First thing I'm gonna do, I'm gonna just sum the moments. I'm gonna use this convention. Counterclockwise are positive, so we're gonna sum the moment at let's just see at G. Okay, it's gonna equal to 0 because the truss is in equilibrium. That assumption we're making. So we have a force here going down that's gonna create a positive moment. Gonna have 2.2308 newtons times the distance. The moment is force times distance. It's gonna be 10 meters. 10 meters. Since this one is creating a counterclockwise, that's positive. This one is gonna create a clockwise moment on this point. So this one is gonna be a negative moment on this one. So you can subtract this from there. It's gonna be minus. I'm gonna call it FAY times the distance, which is 30 meters. Okay, it's all gonna equal to 0. Thus we're gonna solve for FY. FAY is gonna basically move to this side, and then we're gonna divide that 30. It's gonna be 2.2308 Newton times 10 meters times 10 meters. I'm gonna divide that 30 right here. It's gonna be 30 meters. As you can see, the meters are cancelled and we're left with the Newton. That's what we're looking for. Let me get my calculator. Do that. It's gonna be 2.2308 times 10 divide 30 gives me 7. Let me first get rid of the calculator. Okay. Okay, we said let's give me 7. 7, not 3. Okay, let's give me 7436 newtons. Okay, since we have now this force right here, it's equal to 7436 newtons. So we have this one. We can now focus on our cut. I'm gonna just make a sketch. It's not gonna be perfect, but so you can get the idea how the cut works. So we're cutting right here. So this one is gonna be, can still do this. So we have here a force going up, 7436 newtons. And then here we have, imagine this one has two components. It has the fx and the fy, fx. This is fy, and they're all, this is de. So this component. Okay, so now we can just sum the forces in the y. Let me just change the color so it would be easier. Now we're gonna just sum the forces in the y. I'm gonna use this. Up is positive, fy gonna equal to 0. Since we have no forces on the x, we will see this fy right here is equal to this. So that's just logic. Or you can sum them to if you want to, but I'm not gonna do that. So it's obvious that fy is equal or you know what, some of you do you really need this step, so I'm not gonna actually deprive you of that. Okay, let's just see the forces in the y direction. We have here, we have 7 going up, 7436 newton, and then we have this force coming down. It's going to be minus fy, and that's just de, the force of de. It's going to equal to 0. So now we can solve for fy de. It's gonna equal to this number if we just move it to the other side, 7436 newtons. Okay, so now we need to, since this one has two components, we need to know what's the contribution of this force to the whole force. The easy way to think of it, just think of trigonometry. Let's just try to figure out, this is a triangle, right? So we have here 10, it's going to be, this is 5 and this is 5. We're just trying to see what angle this one's going. If we have force coming down, which is this one, we have also force coming this way, right? This is the fx and this is the fy. So we know the magnitude of this one, it's 7436 newtons, but we don't know this one. Since we can use our trig, we can know what is this theta right here. It's this, think of it as a triangle like this, because this is a right triangle here. So we have, this is the x and this is the y. In order to find this theta, we can just see tangent theta is equal, just call this one theta. Tangent theta is equal to the x over the y. Okay, so we know what is the y. We can just call it the x. We can just call it fx, and then we know the fy, which is 7436, right? But this one will come later. But let's just now find what is the value of theta, just based on the geometry. So we have here 5, and then we have this height right here is 15. They already gave us this one, this 15 right here. And then if you look at it from this perspective, you can see this is 10, logically this is 5, and this is 5. And I'm interested at this angle right here, because I already know what the force coming down on this side. or we can draw it here. Just have a little bit of stuff here, so that's why I didn't want to mess things up, make it messy basically. Okay, so we can just change the color real quick and just use the green since we are in the last step. So we have tangent theta is equal to 5 over, this is the x component, over y, which is 15, which comes to about, let's just do it, see what, let me bring the calculator back. Okay, so we have tangent, this is basically, I'm going to just call it inverse tangent, okay? So to get the theta, we have to use the inverse tangent. So let's see if this one has the inverse tangent. You see trigonometry, it should be under the trig. Yeah, it has inverse tangent, which is good. Just do an inverse tangent of 5. But before that, let's see if it's actually in degrees. The easy way to find it, if it's in degrees already, and you can just put sine of 30 degrees, it's gonna give you a half, like 0.5. Okay, it's 0.5. So now we know it's in degrees. We can now proceed with the inverse tangent of 5 over 15. Give me about 18 degrees, 18.434. Okay, so tangent theta is equal to that, so we can just see theta is equal to tan inverse of 5 over 15. So this is basically theta. Okay, and then we said theta is equal to 18 degrees, 435. I would round it to the nearest. Okay, so for the other step now, so we know we need to find these components, right? These components can be calculated. We can use this equation right here, tangent theta. We can just multiply this side, just forget about this side right here. Let me just delete it. This is just was explaining. Okay, so this basically equal to this, right? We can just multiply and then get the fx. So fx, therefore fx is equal to 7436 tangent theta. We know what theta is, 18 degrees, 0.435 degrees. Okay, so now we can just get the calculator again and just calculate that. So we have you can just see 7436 times tangent of theta, which is 18.435, rounding it to the nearest. Okay, so that's will give me 2. I'm gonna just leave the calculator there and copy it real quick. 2478.7 newtons. Okay, for the final step, since now we have we need the force, you see, you need the whole force on this member, so we can just use the magnitude. We need the magnitude of ED, so it's gonna be DE is gonna equal to the square root of Fy square plus Fx square, right? which gonna equal to square root. We know what's this is fx, right? Fy we already calculated a long time ago. It's this one. This is for fy, but they are equal right here. See, I'm gonna just use this one and then erase the. Okay, so this one. So what we have here, we have fy. It's gonna be 7436 newtons square. I'm gonna leave the units for now. Gonna plus 2478.7 square. Okay, so since the calculator is still there, you can just calculate it real quick. Okay, so we have we can use the square root or just convention of the parentheses. You're gonna use 7436 square plus 2478.7 also square, all to the square root, which is just 0.5. Okay, the final answer is 7838 newtons. Okay, let's see what's the closest. I think I might have done something wrong. Okay. Let's see where did I go wrong. So one of the answer should be close. Oh shoot, it's right. It's the D. Sorry about that. I didn't actually see it. I was focusing on this one. So the answer is basically D. Okay. All right. Okay. I think that's it. We can check our answer from the website. Let me get back the. Okay, let's pick our answer. It's this one, and then submit and finish, and then let's see the solution to the answer. Okay, you see it goes really fast if you know what you're doing. You just basically sum the forces, and here's a nice explanation. The carets on this side, and basically just sum the forces at G, which was right here. This is G, and then you get your Fy. Since summing the forces, it's gonna give you the same, and then you just use the shortcut like tangent theta, basically. This is if you look here, we already defined it. You see tangent theta is equal to this. So instead of solving for this, so they just decide to use this one, which is good, yeah. But since you know your trigonometry, I try to give you in-depth explanation. Okay, hope this helped, and see you next time.